In this video, we'll introduce the basics of using a breadboard, which is a device that's commonly used to prototype circuits. Our motivation for using a breadboard comes back to our desire to convert schematics into real-world devices. However, making these devices in a sort of permanent way that you could sell as a product would probably require a lot of time and energy in industrial design. However, making quick prototype devices is quite simple and has been made so by the design of many prototyping aids. The prototyping aid that we're focusing on today is something called a breadboard, which is pictured here. I show two breadboards which have the same circuit on them, one of which has been designed in a careful and high-quality way, the other of which has been designed sort of haphazardly. Both circuits rely on the fact that breadboards have internal connections. Each row of a breadboard is electrically connected, so every hole in this row is electrically in contact with every other hole, and each column of a breadboard is electrically connected. So all of these holes on the column are connected. Notice that these column holes often skip over an exposed area, whereas these row holes don't. When they run into this break in the breadboard, which is referred to as the gutter, they stop being connected. Also, before we move on, sometimes these columns are referred to as rails. Having established that underlying feature of breadboards, we might ask, why is the circuit on the left so much better than the one on the right, in my estimation? The answer is that it's easier to tell what things are connected to each other in the circuit on the left, and also it's easier to disassemble and reassemble the circuit on the left in case anything goes wrong. In the circuit on the right, if I were to look at the orange wire, I have to carefully scrutinize a number of intersections and crossovers and cross-unders to tell what two things it connects to. And if I wanted to remove that orange wire, I would need to take out 3 other wires to get it in and out. That's not true of any wire in the circuit on the left. What this means is that your choices when you design a breadboard circuit really matter for your experience of working with that circuit. Make sure that you build your circuit carefully, and especially try to minimize crossovers and cross-unders, which deeply undermine your ability to work with the circuit. You can get some additional clarity in a circuit by color-coding wires. For instance, the red and black wires in both circuits tend to convey special meaning about power supplies. You can also make your circuit tidy by bending the pins of components that are going to go into your circuit board. For instance, if we look at this resistor, it's got one pin that's been bent over, and that allows you to reduce the total area that a component consumes. In addition, you can make sure that you trim the leads of your components. So this diode is the counterpart to this diode. You'll see that the one on the left rests flatter against the circuit board because its leads have been cut shorter. Finally, one gotcha to keep in mind while designing circuits on a breadboard is that these vertical rails should only be used to carry power. That's because there are hidden elements inside of a breadboard, which arise because of its construction, that make these rails less appropriate for carrying signals that may be in your circuit. You may have noticed that many connections on the breadboard were made using wires, though there are internal connections in each row, which allows them to be useful as a node for a circuit. If you want to connect different nodes together, you need to use an external wire. Doing so requires making a wire from raw material, from an insulated wire, and you do that by using a tool called a wire stripper. The process of stripping a wire is illustrated on the right of this slide, and it requires a delicate touch, but can be mastered with practice. One common use for breadboards is to attach integrated circuits to other elements in order to build electronic systems. Integrated circuits are devices which contain many smaller circuits that give them complex functionality. Integrated circuits interact with the world through many terminals. For instance, the integrated circuit shown on this slide has 8 terminals. Each of those terminals is attached to a piece of metal referred to as a pin. So I'll be using the terms terminal and pin interchangeably. Integrated circuits are represented in many ways in schematics, and one way is shown on the left, where the number of a pin is just written next to the way it's connected to a large box that represents the circuit. However, when integrated circuits are manufactured, their pin arrangement almost always follows a common convention, which is that the upper left pin is pin 1, and the pin numbers increase going counterclockwise around the chip. So 2, 3, 4, 5, 6, 7, 8. You can tell where the top of the chip is in order to figure out the upper left by looking for a divot on the chip. Here's a quick test of your knowledge of breadboarding. Look at the schematic at the top of this page and the breadboarded circuit at the bottom, and try to figure out which node is represented by the green wire in the breadboard. The answer is node B. You can tell that by looking at the two pins that the wire connects to. This side of the green wire connects to this row of the breadboard. And that row of the breadboard is also shared by pin 2, so that we know one side of the green wire is connected to pin 2. This side of the green wire is connected to this row of the breadboard, which connects to pin 6, one terminal of C1, and one terminal of R2. Now if we look at the schematic, only one node fits that description of connecting to C1, pin 2, pin 6, and R2. Here are the key takeaways. First, breadboards are one way to construct circuits. They have hidden wires which connect each row and each column. The columns are sometimes called rails. Each half of a row is separated by something called a gutter, which is designed so that you can fit an integrated circuit over it. And carefully constructed layouts make breadboarding much easier. Seriously, I can't overemphasize how much simpler your life will be if you lay out carefully. Integrated circuits are common in many terminal devices, and integrated circuit pins are numbered, such that number 1 is at the upper left and the pin count increases counterclockwise.